Well, welcome back, listeners, to the Dairy Science Digest. This is a podcast designed to bring the Journal of Dairy Science straight to the ears of dairy producers. I'm Reagan Bluell from the University of Missouri Dairy Team, and each month I feature a new, fresh research article in press. And kicking off the third season of this podcast, Dr. Tracy Burnett joins us today from the University of British Columbia in Vancouver, Canada. She's here to talk about her team's research article currently in press titled The Impact of GnRH Administration at the Time of AI on Conception Risk and its Association with Estrus Expression. And so really, if I were to distill that down, you were watching cattle with activity monitors and learning about what GnRH did with that. So before we get going, Doc, could you tell us a little bit about yourself and about your project?
Sure. Yeah, I did most of my grad school at the University of British Columbia. I originally did research more with stress and cortisol and how that related to reproduction. And then for my PhD, which this paper was part of, I focused a lot on estrus expression and how it relates with fertility. We had kind of shown time and again, we showed that if cows are moving more, whether that's more steps or just more activity, that they have higher fertility. So we've shown that previously after timed AI protocols, but also after just spontaneous estrus, like a cow coming naturally into estrus. So what we found with that research was that cows that don't move a lot, they have lower fertility. This portion of my PhD thesis was trying to figure out if there was anything that we could do to increase the fertility of the cows that had low estrus expression. One of our hypotheses was that it was an issue with ovulation. So if we gave GnRH at breeding, that hopefully it would kind of fix this issue with infertility of those cows.
Sure. Those trouble breeders that we know never show heat, and we're trying to get them to settle. And so you employed 3 producer farms up there, and there were 2,607 estrus detections that you guys were monitoring. And these animals were sorted out, and looking at their activity, you took the average activity over the farm, and they either had a high activity or a low activity. And then within each one of those, they either got a GnRH treatment or a control, and really teased out the data under those classifications. So did GnRH work for the ones that had high estrus activity that typically are not really breeding problems? Did we see a benefit to GnRH in those cows?
No. So that's kind of one of our major kind of take homes from this, is that there wasn't really a benefit to giving that GnRH treatment at AI to cows that already have good estrus expression. So the cows that you're seeing, going crazy, running everywhere, probably she's not going to have such a big benefit by getting GnRH at AI as the ones that have the low estrus expression.
That is a question that I get all the time. And so guys, if you're listening closely, she had an ultrasound to determine whether or not that animal was ovulating or not. And they don't need it. They don't need that GnRH, because this is a tool that we've had in our reproductive toolbox for a very long time, early 90s, right? Is that when we learned about the GnRH that caused the LH spike and improved ovulation. But now we're learning how to use this tool and kind of refine it. And just because it's affordable doesn't necessarily mean that we should use it ubiquitously. And so kind of really focusing in. Tell me a little bit more, what kind of interactions did you see?
So as I said, our hypothesis was based that it was all due to ovulation. And that's why these cows that aren't having a very good estrus expression were having lower fertility. But science doesn't always, I guess what we say is the cows don't always read the book. So we actually did not prove that at all. We just proved that giving GnRH was helpful to cows that had low estrus expression, but it wasn't because of ovulation. That was a very big finding for us, that although So the ovulation results kind of went the opposite to the fertility. So we found that when we gave GnRH to cows with high estrus expression, they actually did ovulate a little bit more, but it didn't change the fertility outcome. And when we gave GnRH to cows with low estrus expression, it didn't really change their ovulation, but they had higher fertility.
Isn't that incredible? Yeah, if we focus in on those lower intensity, so the cows that are hiding their estrus, and the ones that got the GnRH, their pregnancies per AI was 37.8 versus the control at 31.0. So we're really talking quite a few points improvement for those problem breeders. And I think, and I'm calling them problem breeders, but I wonder if we can utilize this knowledge for those historical problem breeders and utilize that GnRH maybe at first or second service before they become a problem in the next lactation, and maybe retool these animals and all of a sudden they're no longer a problem.
So we did look a little bit at what insemination number the cow was postpartum. And generally speaking, if you include, so we had breedings that went from first AI all the way up to, I think, 11th AI across all these three herds. And we did find that if we took out the super late insemination, so we just kept it to 1 to 5 inseminations, that none of the cows within that group were better off with GnRH. Everyone had the same response. So better for low estrus expression cows. So it does seem to be consistent across the way, but when you get out and down toward breeder, super repeat breeders, I guess you want to say, we did find that GnRH might help a little bit more, but also that the difference in estrus expression, the fertility between high and low estrus expression, there wasn't that big of a gap. When you get out to a cow that you've bred 10 times, there's more problems there than we can really just solve by giving a GnRH shot. She probably has some other issues going on.
Yeah, some unexpected or spontaneous ovulation that's just not, she is not reading the book. She's a problem child. And so I guess as I was reading this, I was really compelled to ask, did they use OffSync, or what synchronization program did the producers use? Was it uniform across the full grouping of 2,600 animals?
That's actually something really good to bring up, that all these three farms were really used to using activity monitors to breed their cows. So they only used the actual protocol, let's say an OffSync, for cows that they couldn't find in heat. So if they all had kind of cutoffs that at some point they would enroll those cows onto OffSyncs and breed them off of timed AI. But all three farms, vast majority of their inseminations were just off spontaneous estrus. So they didn't use any sort of protocol, but they were all very used to using the monitors. So that's another, I think, important part, because sometimes producers aren't either way, right? Producers aren't used to breeding off of monitors, or maybe they're not used to giving hormone protocols. They can kind of fail at either method, right? But specifically for this one, they were all producers that were very used to using the monitors and finding cows in heat that way.
Sure. For those listeners out there that do not have activity monitors, it's really actually quite incredible how resourceful they are. And just to kind of reiterate or give a little bit of background on that, every animal has their own individual average. And when they deviate from their average, you can track it very easily across the screen. You can see boop, 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 and then it spikes tenfold. And then 21 days later, it spikes tenfold. And then 21 days later, it doesn't, because you got her pregnant off of a natural heat. And it feels very marvelous. But those of you that are graced with activity monitors, I think this is a really important article for you guys to recognize that it can really help save some costs. And if you're currently utilizing GnRH to help with that ovulation process, you don't need to anymore, I think, is what your data is saying. Is that what you would summarize for your boots on the ground dairy producers for this particular project?
Yeah, so I would say focus the use of GnRH at AI on the cows with low estrus expression. And just to follow up on that, so we have also looked at, so some producer might not have the activity monitor, but they might use some sort of like tail chalk type technology, like an estrotech or a chalk. And we found the same results in terms of estrus expression on fertility. So the more chalk there's rubbed off, or like more ink, that shows that has been more mounting on that animal with the tail chalk, they have higher fertility. So we didn't do that here in this paper, but I would assume that if you have a cow that the tail chalk is not rubbed that much, but you think that she is in heat, she might be a good candidate for GnRH, just to increase her fertility a little bit.
Fantastic. Well, that's excellent boots on the ground advice for day-to-day dairying. So in your paper, you reported that for every increase in your 305 mature equivalent milk yield of 2,200 pounds, or a 1,000 kilogram increase of milk yield, associated to a 1% decrease in pregnancy per AI. Could you explain how or why? What do you think is happening? What mechanism is happening there with that high producing milk cow?
We didn't see like an interaction with the GnRH treatment. So it was just kind of like an overall, we saw cows that produced more had lower fertility, but there wasn't a difference when we gave GnRH. They reacted the same way. In the terms of higher producing cows having lower fertility, it has been researched before that they will have lower fertility, and it's kind of related to the blood, like how much food they eat. So the more they eat, the more blood flow they have in their body, and especially to their liver. And then the liver will clear the hormones faster from their body. So it does make sense that these cows have lower fertility, just because they won't have as high estradiol at estrus. And there's also some relationship with progesterone as well. So that's what I would probably go to as a reason behind the milk production relationship with pregnancy and fertility.
So I was reading in your article that I noticed that there seems to be an impact in the duration of estrus. Could you speak a little bit about the interval of time between estrus detection and time of breeding?
So 2 of our farms, they bred by the AM/PM rule, so twice a day. And one of our farms only bred once a day. So that made it so we had a bit of a difference in terms of hours from alert to the time of breeding. And so what we found anyway with estrus expression, so if we look at the control, so cows that didn't receive GnRH, the longer you go from within reason, right, from the alert, the cows that had greater estrus expression, they had higher fertility being left a little bit longer. Whereas the cows with low fertility, the longer you waited, their pregnancy per AI like plummeted. Yeah. So when you give GnRH, especially if you have a little bit of time that has passed, it seems to kind of dampen these effects of the cows with low estrus expression plummeting in fertility.
Super sensitive. Yeah. Okay. I see. I am really pondering that, because you would think that those low estrus cows plummeting is because they ovulated and you're not meeting it with semen. But that, I guess, so they had to have that LH surge at that moment in order for the ovulation. But you're saying that if it's the once a day farm, if given GnRH and they still bred her longer, since let's say it was 22 hours, she still ovulated?
Yeah. So that's okay. This is interesting. So what the hypothesis is that, so the cows with low estrus expression, that they have like a suboptimal LH surge. So then when you go again and you give GnRH, you're kind of instigating them to have another one.
Yeah.
And where that becomes important, we think, is after in the formation of the corpus luteum.
Has enough progesterone.
Yeah. So that's actually something that we're doing now, is looking at how functional the CL is after. And so the idea would be that if, let's say, we don't know this for sure, but let's say there was a second surge because we gave the GnRH,
do-over,
that maybe that, yeah, exactly. Let's have this a do-over, that the corpus luteum is going to be producing more progesterone after AI, and it's going to support gestation better.
Sounds like a very viable hypothesis, and I can't wait till that paper comes out so we can highlight that also. Yes. All right. Well, and ultimately, in the end, your stats didn't show any difference between Farm A, Farm B, or Farm C, right? And so does that give us the authority to breed once a day?
That's a difficult question. What I think is really nice is, even though the farms were managed differently, we still found that low expression cows were benefiting GnRH no matter what, no matter if you bred twice a day or once a day. And if you look at the data, the cows are different. Everything's different behind them. Like the design of the barn's different. So I think that the results in that way are very
representative of all the different types of management.
Thank you. Yes, representative. In terms of the once a day versus twice a day, that's a very hard question for me, I would say. I'm not sure. I know most of the previous research does support more of the twice a day breeding. But I also know that there are many, many farms that succeed very well with once a day breeding. So I think it's probably very farm dependent.
And I suspect also it sounds like your high producing cows are going to be just a little more delicate and maybe a little less tolerant of those management stretches. And so you just got to know your herd and understand where you're at and how tight that tightrope is to be effective. Well, very good. Fantastic. Well, that's an excellent boots on the ground advice for day-to-day dairying. Well, Dr. Burnett, this has been very informative, and I want to thank you for your time. And listeners, I applaud you guys for taking time out of your day to learn about how to best apply GnRH in your reproductive program or breeding program. I've really enjoyed our conversation, and this has been the January edition of the Dairy Science Digest, which is a monthly podcast project designed to bring the Journal of Dairy Science straight to your ears. We highlight peer-reviewed research articles in press, and this is sound science to base your management decisions around, provided by your University of Missouri Dairy team. So be sure to like, share, and subscribe to get future editions straight to your cell phone. This is Reagan Bluell with Dairy Science Digest, and I hope you have a great day.